So this is the high-level rational functions, problem number 3. We're going to start like we do with everything else, and we are going to see if we can factor and cancel. So we've got x cubed minus 1, which is going to factor into x minus 1 times x squared plus x plus 1. All over x plus 1. So that while it factored, there's nothing that canceled. So there are no holes in this graph. So not terribly helpful that way. X-intercept, I want to set the numerator equal to 0. And for this one, I'm actually going to go with the original numerator, which is going to be, let's see, the numerator is x cubed minus 1. I'm going to set that equal to 0. So it's going to be x cubed is equal to 1. If I take the cube root of both sides, I'm only going to get x is equal to 1. So that gives me an x-intercept of 1, 0. All right, y-intercept, I'm going to take, again, the original function here because the simplified version really isn't that simplified. So I'm going to take the original version, make x is equal to 0, and see what I get here. That was supposed to be a cube. So let me actually write 0 cubed. There we go. Minus 1 over 0 plus 1. So negative 1 over 1 is just negative 1. So 0, negative 1. Vertical asymptote. Set the denominator equal to 0. So x is equal to negative 1. We're going to take a look at our horizontal versus other asymptote here, and we want to look at the degrees. So we have a third degree over a first degree, which means there is no horizontal asymptote. You have an other asymptote here. So I'm going to find that other asymptote by doing synthetic division. So x plus 1 is what I'm dividing by. So I'm going to turn that positive 1 to a negative 1. And then I want the coefficients. But I need to make sure, again, that I have all those placeholders for the x cubed. So the coefficient of x cubed is 1. The coefficient of x squared is 0. Coefficient of x is 0. And the constant is negative 1. Little room to work here. We're going to go ahead and drop that one straight down. So let's see, 1, negative 1. Add vertically 1, that's going to be 1. Let's multiply, add vertically. Okay, so if I label what we just came up with, remainder constant x squared. Okay, so that's nice. All right, and what that then gives me is an oblique asymptote. Whoop, actually, it's not oblique, it's parabolic. So it's the other asymptote is x squared minus 1x plus 1, okay? And so that remainder doesn't matter for us. Now, I don't know about you, but it's been a while since I have needed to graph x squared minus 1x plus 0. So if you need to grab a graphing calculator for this, I'm actually going to do a quick little table of values just to get some information on where this graph is so that I can get some good information and figure out what's going on for the overall picture of it. Okay. So I just want a few values here just to get an idea of what this function looks like. So table of values here, x, y, let's do, I don't know, negative 2, negative 1, 0, 1, and 2. All right, so negative 2 would be negative 2 squared minus times negative 2 plus 1. So 4, 6, 7, yeah, I think it's 7. There we go. Sorry for the little pause there. I'm trying to do the math in my brain. So let's go ahead and do negative 1 here. See if I can be any faster with that one. 1, 1, and 1 would be 3. 0 is going to be the easiest one. That's just going to be 1. All right, positive 1. Now I got to pay attention to my signs a little bit better. So 1, negative 1, and 1 would be 1. and 2 squared. 1 times 2 plus 1. So 4 minus 2 plus 1 would be 3. Okay. All right, so I'm going to use that information when I go ahead and graph the oblique asymptote. I keep calling it oblique. It's actually parabolic. So when I graph that parabolic asymptote, I've got some information for it. All right, so I'm going to take all this mess of information, and it is a mess of information, and actually put it on the graph. All right, so 1, 0, 1, 0, 0, -1. And right now I'm just moving back and forth so I can get this information. All right, so vertical and horizontal asymptotes. I said horizontal, it's actually the other asymptote. All right, vertical is x is equal to -1. All right, so right here. And then I have to graph my other asymptote, which is going to be using this information. So this, remember, is an asymptote, and so I want to be careful that I'm graphing the right pieces. So it was -2, -7, -1, 3, 0, 1, 1, 0, 2, 3. All right, so I'm going to use what I know about quadratics here, because this is parabolic. Wow, that's horrible looking. Hold on a second. All right, let me back up and make that look slightly better. Okay, let me zoom in here. All right, and all I'm doing right now is just marking through these points to get the feel for what the asymptote looks like. All right, it looks weird. I know, all right, I get it. The thing that we need to figure out right now is where is the other part of this graph, okay? Because if we look at the vertical asymptote, I clearly have both of my points that I know to the right. I have no idea what's going on to the left. So that's what I've got to figure out. So let's see what we've got here. Let's go ahead and pick -2 and see what happens there, all right? And one thing you got to be careful about is that -2 needs to go back in the original, okay? So if I go back to the original here, and I'm going to mark this as an extra point. All right, extra. I'm trying to apparently make that as one word, extra point. All right, let's say x is equal to -2. All right, that gives us a y value of -2 cubed minus 1 over -2 plus 1. Okay. -2 cubed is -8. -8 minus 1 would be -9. -2 plus 1 is -1. So this turns into 9. We have an extra point at -2, +9. Okay. So I'm going to slide back down to my graph and graph that point as best I can, because apparently I've now run out of curve. So -2... There's 8. 9 is going to fit right in here. Okay. So I'm going to actually extend my two asymptotes just a little bit. Oops. Let me again narrow those back down. Okay. So we know this vertical one's just going to keep going straight up. This quadratic is going to start slowly, but it will eventually do this. It's going to start getting further and further away. It keeps getting wider and wider out, okay? So when I go to graph this, right, we're going to approach the vertical asymptote. I'm coming in from +1 there, all right, my y-intercept. I'm going to curve through the x-intercept and then approach this parabolic asymptote. Now, the other point that we're dealing with basically sits between these two asymptotes, this vertical asymptote and this parabolic asymptote. So we're going to approach both, all right? So we're coming in from the vertical. Make sure you hit that point. It's going to curve up and then basically follow the curve of the parabola. All right, it looks weird and goofy, but that's what it is. All right. I'm going to go ahead and close this video out on problem number 3, and there'll be a separate video for problem number 4.